Hello students, in the previous video I discussed about techniques on concentration of ore. We are discussing metallurgy in a series of videos now. Now in this we are going to see the extraction techniques, converting the ore to the metal oxide, how we can convert ore to the metal oxide, and this is the next step after concentration. So keep watching. Converting ore to the metal oxide. What is ore? Ore is the selected mineral. The ore is converted to metal oxide after the concentration. In the previous video I discussed about concentration techniques also. Now various methods involved in converting ore to the metal oxide. So because the ore can be different, it may not be oxide. Some are oxide, some are carbonate, some are sulfides, and so on. So the first method is called roasting. What is roasting? Roasting is the heating of the powdered ore in the presence of air. See, two important things. Ore is powdered and then heating in air, presence of air. The ore is first crushed into small pieces, then it is powdered. The powdered form is taken, then it is heated with abundant supply of air, constant stirring. An open container, stirring is there, and constant supply. Or if you are using closed container, then you have to pump hot air into it. Okay. Generally, sulfide ores are roasted. This is important point to note. What kind of ores are roasted? It is sulfide ores. The metal sulfide changes to metal oxide and sulfur dioxide gas is evolved. Okay, so two products are there, metal oxide, another one is sulfur dioxide, which is a byproduct. The metal oxide is carried to the next stage for the extraction of metal, and the sulfur dioxide evolved can be used for the manufacture of sulfuric acid in the contact process. So here is a simple diagram that will show how the roasting is done. So we have the hopper through which the powdered ore is coming in, and and then you can find the particle collector is here, and you find the cooling trays here. So this is cooling. After the burners are here, it is heating and air is being supplied. So it is all powdered. Finally the product will come here. Now the cooling tray, the airflow is this way, the hot air is going outside like this. So finally you get here simply the ore plus heat plus air. Okay, so three things are there. So the reaction will happen. So no need to go into details of the diagram, just to understand what is happening here. Now let us see the reactions involved, how it is. Example, zinc sulfide, which is taken, which is otherwise called galena, which is roasted on heating with the oxygen. Oxygen is required. So you get zinc oxide plus sulfur dioxide. The product sulfur dioxide is a gas which will be evolved. Okay, so how do you balance this? 2ZnO, 2ZnS, and 2SO2 and 3O2. 3O2. Okay, so it is balanced. So this one is iron pyrite. Iron pyrite. So this one is zinc blende. Zinc blende. So iron pyrite on heating will give Fe2O3, roasting. Okay, so here again heating sign will be there. Fe2O3 plus SO2, sulfur dioxide. So we have Fe2O3. We have to make it even number. So 2 Fe2O3. 2 Fe2 means 4 iron Fe. So 4 FeS2. 4 into S2 is 8 sulfur. 8 sulfur. 8 2s are 16 and 2 3s are 6. So 22. So we have 11 O2. So it is balanced. This reaction is balanced. So we have Fe2O3 coming up. So roasting will give you metal oxide and sulfur dioxide. Okay. Then we have the next technique called calcination. Calcination is heating the powdered ore in the absence of air or a very limited supply of air. So roasting and calcination, what is the big difference? In both cases we are heating the powdered ore. In the roasting we are supplying abundant supply of air, whereas in calcination we are giving very limited supply of air and sometimes no air. Okay. So what kind of ores are calcinated? Calcination is done for carbonate ores. Carbonate ores. Okay. Metal carbonate decomposes to give metal oxide and carbon dioxide gas. So this is the change here. The metal oxide obtained is carried forward to the next step in the extraction, that is to get the metal. Carbon dioxide can be used for preparation or manufacture of aerated drinks, carbonated drinks, cold drinks we make. Carbon dioxide is required there. Now, see, there can be constructive use as well as destructive use. This carbon dioxide, if it is not used for manufacture of aerated drinks, it is let into the air. It will cause pollution, greenhouse effect is caused. Same way in the roasting also, if we don't, the sulfur dioxide is evolved here. If we don't use it for manufacturing, release into the air, it will cause acid rain, it will cause respiratory disease, it will cause serious problems. Okay. So we can use it constructively or destructively. It is upon us. Now, this is where we are showing the calcination. What is being done here? Exhaust fan is used here to blow air into it. The limestone is dropped inside. Limestone is calcium carbonate. The heating is done from here. Air is sent from here and heating. The fuel is heated here, burned. The fuel burns, heat is produced. Okay. Anyway, the reaction involved is if you take zinc carbonate, okay, which is otherwise called calamine, you get zinc oxide and carbon dioxide. Okay, so a very simple reaction. The metal carbonate splits to give metal oxide and carbon dioxide. So students, I hope you understood the various techniques used in converting the metal ore to the metal oxide. In the next video, I will be talking about reduction of the metal oxide. So you can subscribe the channel and watch. Thank you.